probably stop around 7, a little bit before 7, and give you the handouts. Now, with the handouts, the 4 o'clock session, Mr. Park's session, the math lab is open almost all the time. Really, me as an instructor, I see no excuse in a student not doing well if you have all that support. The thing is, though, you gotta get to it. If all that support is there, like I said, the 4 o'clock session, I'm there Mondays and Wednesdays. Mr. Park, I think you're also on Mondays and Wednesdays at a different time. He's there. The math lab is constantly open. You can always stop by there. Handouts. I have plenty of handouts for you guys to look at. And review for a test. I always have a handout for a review for a test. So all that. So I don't want anyone to do all this and all of a sudden at the end they get a fail. I guess we're here, we come to class, and if you don't come to class, you know I drop you. First I warn you. I sent out some emails today. You are warned. You did not show up for the exam last Wednesday. You missed the exam. Now if it's a good excuse, I understand. But if it's not a good excuse, no, you're out. How can you do that? You can't do that, so be here, okay? So guys, here's what I need to do, and also like I said, I got to research some time. I'm gonna stop around 7 and get that handout to you guys and see what happens here. But before I do that, let me do this. Part 1, let's make a little connection here if I can. Part 1 is this. Find the average rate of change of this function. I brought in this one, f of x is equal to 3x squared plus x from 1 to 7. I'll just make that 1 to 4. Look at my numbers here. So find the average rate of change of that function as you travel on it. I'm not going to sketch it. I did a sketch before the break. Without a sketch, and we'll know what is the average rate of change as you travel along that graph of that function, and you're going from 1 to 4. Now, your textbook does this. I had a little discussion before the break as to what this means, which I think the textbook did too, but they give you this description. So since they did it, I'm going to do it. Here's the way they describe it. Average rate of change. Let me just abbreviate here. And you have no graph to refer to, but they ask you to find it. Find the average rate of change without a graph. Find the average rate of change from, add this, from A to B. Find the average rate of change from A to B for a function whose graph may be provided and not provided. And they're telling me it is, look at this, here's what you do. They describe it as change in y over change in x, delta y over delta x, that's slope. And they say to find it, you can do this. Find f at b, subtract f at a over b minus a. Now we're going to try that. Now, when I do it, you'll say, Professor, I really think it comes down to slope. That's what they're asking to find. Delta y over delta x, slope. But your textbook says find the average rate of change. They give you also like a little formula to follow, if you wish. You guys find the average rate of change of that function, no graph provided, from 1 to 4. Now, what I would do if I want to use the formula they gave me in the textbook, I would do this. Well, they gave me 1, that's the x. They did not name the full point for me. How can I find the y? They just said you're going from 1 to 4, and those are my 2 points. 1 and what is its coordinate? What's the y coordinate? What can I do to find the y coordinate? Yes? Plug in. Just go up here and plug in 1. And guys, quickly, I think if you plug in 1 up here and do the calculation, please help me. Is it 4? Yeah. Okay, so that means now I have a full point to work with, like I did on the sketch before you guys took a break. Here, same thing. They gave me 4, but they did not name the full point for me. So if I plug in 4 and calculate, I think I get 48 plus 4. See if I'm right. Is that 48 plus 4, which I think is 52? Big number, but that's fine. Those are my points. Now, if you want to label them to apply this formula, if you like formulas, if you want to apply the formula, this is A, this is f of A, this is B, this is f of B. They found it by just applying a formula. A, f of A, B, f of B, and then go down here and make replacements. And you'll have what they call the average rate of change, which is really slow. Now, if I do it on this one, guys, f at B is 52. Subtract f of A, we found that to be a 4. Just make replacements. B minus A, it looks like it's 4, subtract 1. If I put them in there correctly. Just make replacements. 52 subtract 4, guys, what is that, 48? Over what, 3? Look at that, 16. If I did the arithmetic correctly. So we're going to accept 16 as, look at this, the slope. I know it's a steep number. I just created these numbers right quickly, but this is to represent the slope connecting these 2 points. And I don't have the graph in front of me, so I did it without a graph. So if I give you the 2 points, many students will refer to this formula, but it really comes out to be slope. Now, if you don't want the formula, and as you find the average rate of change, you say, wait, Professor, I thought you said it's merely slope for middle school. Maybe I don't want to use that rate formula. It's easy to use though, but I just want to use the slope. The slope in this case, delta y over delta x, change in y, look at this. Change in x, delta x. Guys, as I make my replacements, here we go. I can label this one as the x1, y1 if I wish. This point could be labeled as x2. Here's an alternative to the problem. And then plug in. Okay, y1 subtract y2 would be 4 subtract 52. And in my slope formula, standard slope formula, x1 minus x2, the way I have mine labeled, would be 1 subtract 4. So it looks like I'm going to end up with a negative 48 over a negative 3. Oh my goodness, same answer. So it's up to you. Many students were like this. They'll do this and say, this will give it to me, Professor, it will. This will give me the average rate of change. This comes out to be slope for middle school, average rate of change. They didn't call it average rate of change back in middle school. They just called it slope, but it's actually average rate of change. Guys, any concerns here? So use the formula or just use the standard slope formula. Now if they ask you to write the equation of the secant line, to finish this up, the line that connects those 2 points, and I don't have the graph in front of me, I would go directly to this point slope form, as I mentioned right before the break, and make replacements. And what type of replacements can I make here? It's y subtract y1. Y1, the way I labeled mine was 4. Slope is 16. Strange slope. X subtract x1. X1, the way I labeled, was a 1. Let me step back and make sure I put all those in there correctly. I think I did. Okay, beautiful. Clean this up. Y subtract 4 is equal to 16x subtract 16. Get the y by itself. 16x minus 12. There's your mx plus b form. There's your equation of the line connecting the 2 points or the secant line. That's the name they give for the line. And I see no graph at all here. So there's an alternative, just no graph, just use the formula and go from there. Guys, look at it closely. Like the last time I discussed this. Are we okay with this? Average rate of change, nothing but slope, and then go from there. So I thought I'd point that out first. Now, Kyle, I keep on referring back to you. Before I move into something completely different, he was asking last week, he says, Professor, let's connect all this with this. Let's go to a graph. Guys, we've done a lot of work tonight. Let's go to a graph. Let's say the graph looks like this. It's in red. Let's say it looks like that. And sure enough, I have, hang on now, a point here on that red graph, and a point here, and my function, which is called f of x, we passed the vertical line test, it's the function, graph of function. And I'm interested in getting from this point to that point, traveling along that red graph. Thinking back, same discussion we had before the break. So here's my initial point, here's my terminal point, stay on the red graph, move from one to the other. Now I'm gonna label these points in a manner you haven't seen yet. Rather than use numbers, I'm gonna call this point right here, x, f of x. It's a general point. I will not give you specific numbers this time. X, f of x. Now if I label this point with coordinates, you know this point is different than this one. They are different, aren't they? Guess how they represent showing that they are different? They call the x coordinate, this is x here, I can't use x. They're going to label this as, to show it's different, a different point, x plus h. That's where the h comes in. Shows it's different than the first point. And then, of course, the y-coordinate would be, look at this. The y-coordinate, does anyone think they know what the y-coordinate would be represented as if the x is x plus h? What do you think it is? Anyone? Down here it's f of x for the y-coordinate. What do you think the y-coordinate may look like on this one? Where the x-coordinate is x plus h. Go for it.
F of x plus h.
F of x plus h. Absolutely. Those are my 2 points labeled. No numbers, no specific numbers to work with. Then, of course, what I did before the break, you know what I did? I connected the two. Show a straight line connecting the 2 points. Probably look like this. Rough sketch. Line connecting those 2 points, and then we're supposed to find the slope, or the average rate of change, back to slope. So if I find the slope in this case, that's delta y over delta x. Change in y, change in x. We did that earlier. I got to point this out before I leave this. I think there's a nice lesson to show you a conclusion here. Now it says subtract the y, subtract the x's for those 2 points, and see what happens. Guys, to subtract the numbers there, I'm going to label this one as my x1, y1, so I can use it. And I'm going to let this point represent the x2, y2 in my slope formula. And just use it. It says y1, the way I have mine labeled is f of x. You know what? Let me turn this around for a reason. Let me do this, which I could. Let me let this one be the x2, y2. Now, y1 now is f of x plus h. Subtract y2 in my slope formula. Y2, the way I have mine labeled now, is f of x. Over, in my slope formula, x1 subtract x2. x1, the way I have mine labeled, is x plus h. Subtract x2, I have x2 merely as x. Kyle, what happens? If I set this up for slope, which I did, and I did it correctly, I hope everything's correct here, and I simplify this, what's going to happen is you're going to end up with what? F of x plus h, subtract f of x, and in that denominator, what happens? will the x's cancel?
Yes.
What's left?
E.
And what was that?
Difference.
That's called the difference quotient. That's where that H came in, Kyle. That's where that H came in all these textbooks. And he was asking, I'd be wondering also as a student, H? So I go to Berkeley and see an H, what's H representing? And it's just representing that this point right here is different than this point. And they show that difference by putting plus H. They could have put a plus E, plus F, something just to show the two are not the same point. They're different points. They find the slope, and look what happened. It's a difference quotient. So the difference quotient is nothing but slope, just to confirm that. Now that said though, that's done, we're finished with that, that's nice. Part 2, then we'll stop. Let you guys do a few things for me. To close down tonight, I need to quickly take a look at just a few of these. Piecewise defined functions. Now, before I give you an example, just a word, piecewise defined functions, these functions will be given to you as f of x, g of x, h of x, same notation, but they're going to be given to you in pieces. Now, you know what's strange? All of a sudden, you as a professor, finally I sort of see how the graph's just a function. Give me f of x equals x squared plus 2, I think I could graph it. Now you're going to say, now they're going to give it to me in pieces, like this. Sketch this function. Look at this, guys. This first one's going to be given to you in 2 pieces. Not just 1 piece, 2 pieces. F of x is equal to, first piece looks like this. X if this is true. Use a different color. Negative x if this is true. They're called piecewise functions. This one's 2 pieces. On the exams, by the time you finally have an exam on this, and I get a chance to do more of these, I usually have on the exams at least 4 pieces. This one has only 2 to worry about. Okay, guys, you see what this will happen here. And I'm going to throw this out to my class before I graph it. Because I saw on the exam some clever work being done. So I have quite a few clever students in class. Does anyone think they know when I finally finish up and graph those 2 pieces of the same grid, what shape is it? Does anyone think they know at this point before I do it what the final shape of that function given in 2 pieces, what the shape looks like? Is it a parabola? Okay, no. Is it a straight line, Professor? No. Is it one of those strange graphs, Professor, with the local max, local min, all that business? No. It's one of the parent functions. It's one of the parent functions. Now, which one is it? Is it a square root function, Professor? No. Parabola? No. Cubic? No. Help me out.
It's 1 over x.
It's not 1 over x. I see why you said that, though. I see what you were thinking. Not 1 over x. Katie?
Is it the integer graph?
Not that. You mean that greatest integer function, that crazy one with the little steps? Not that one. One more simple than that. A little much more simple than that. Yes?
The identity function?
And not the identity function. I love this. That's why I love teaching. Not the identity function. But I can see why you guys are saying that. Let me see what it is. It's going to be one of those on the handout. It's going to graph into one of those from the handout. Now what I would do, here we go, guys have different colors going for me. On the side here, I would do this, because this is new for us. I would construct a little table, because we're going to plot a few points, and create some points in a table for that black piece there. Now notice the restriction says, go ahead and do that, professor, but make sure your x is greater than or equal to 0. So in my XY table for middle school, I'm gonna start with 0. They gave 0 to me, so I'm gonna start with 0. Now what am I supposed to do with it? Well, they named the function as this. Just saying, go back, this is your function here, this is like f of x. So go back to that first piece, which is merely x, put in your 0, and of course you're going to end up with 0. That's more like that. That's your first order pair. Now, can anyone tell me, based on the condition they gave me, what else am I allowed to try besides 0? It says anything greater than 0. That's quite a few numbers. So I'm going to try 1 just at random, just choose a number, I'm going to try 2. If I put 2 here, go back, put it into my function, which is the basic function, x, of course you get 2. I can try 3 with 3, 4 with 4, 1/2 with 1/2, 1/3 with 1/3. And then they're saying after you get all those, plot them. I think 2 points will be enough to see what's happening on the first piece. Let's see what happens here, guys. So if I plot in the black, 0, 0, and notice the equals mark there says you may include 0. It may be darkened in. My next point is out to, up to. So just be very careful. And that point would be right there. If I want to try 3, 3 in the table, which would be in the table if you wish, plot 3, 3, 4, 4, you'll find when you connect, these points will connect like this. That's the first piece. Done. It's everything to the right of 0. The other piece I'll graph in red. I need to form a table for the red. Now, if I want to form a table and create some points, my restriction is these x values must be less than 0. Well, they gave 0 to me, so we'll put 0 in there to begin with. Now, I'll give you something less than 0, which is also allowed. -1. You could try -2, -3, -1 1/2. I think for this particular graph, I think that those two will be enough to see what's happening. Now, if I take the 0 back and put it in right here, be careful, it says -0, which is 0. That's my first point. I'll take -1, which is less than 0, I can use it. If I replace in my function, which is -x in the red, if I replace x with a -1 with a negative sign out front, it turns into a +1. You guys agree? Just create a table. I think there'll be enough. So I'm going to plot, guys, and I said 0, 0. Now notice I used 0 because they gave 0 to me. But was there an equals mark on the inequality symbol? No, I'm not supposed to use it, but was it being used from the first piece? I picked it up already, so I can't reopen it, so it's got to stay closed because it's closed from the first piece. The other point's out, -1, up 1. Let me put this in red. That's -1, up 1. And please keep in mind, it's got to connect with this point from the previous. If I do, 2 points there, something like this. There's a red one. Now please tell me, on that handout, or maybe in our discussion, which of all the parent functions can you imagine, not many students would recognize this. This was one of the parent functions. Which one was it? Absolute value of x. This is equal to 6. Who would have thought? It was given to me in 2 pieces. It graphs into the V-shaped absolute value function. And that's the piecewise function. Now I'm watching carefully. Hang on. Maybe we'll have 30 minutes to work on something for me here shortly. Besides that, yes, I'm going to close down this. Good. This one's not too bad. I like to graph. This one has 3 pieces. Okay, here we go, guys. Part B. Then I'm going to stop. I'm going to call this G of X. For 3 pieces. Piecewise functions. First piece looks like this. I'll put it in blue. 2x plus 5 if Here's my constraint, condition that must be met. That first piece in the blue is only true for that particular interval. Now the next piece, this one has 3. Oh, the second piece, I'll put it in red, looks like this. -3 if this. That's all it says. Third, we'll try the green, if the green will hold up for me. Green looks like this. X squared plus 1 if this is true. X is greater than 0. Oh, this is nice to be in class with. Oh, this is super nice. To stop class with. Okay. Mr. Parker, is the viewership, are we getting lots of views on the video when we send it out?
Let me check.
You check and let me see if students are turning to it for help. I hope so. Okay, guys, on the graph. Here we go. Let's get the blue one out of the way first. By the way, the blue one, if I know my mathematics, we do, you know 2x plus 5 takes this form. It's in the form of x plus b. So it should graph into a straight line. Now, am I going to get the full straight line with a slope of 2 and a y-intercept of 5? No, I'm going to get a piece of it. That's why they call these piecewise functions. I would do like I did here. I'm going to create a table on the side here to help myself out and create a few points. Now, notice they said I can try -3, so I'll use -3 at the table, and I go to 0. I'll put 0 there. Implied, I can try also anything in between. You're caught between -3 and 0, quite a few numbers in between. I think I just need one more. Let's try -2. It's up to you. Now, -3 was given to me. I'm going to take it back to my function. Now, this one has a little busy work. You got to replace x by -3. Plug this in, do the work, guys. I think you end up with a -1. And that's my first ordered pair. -2 taken back that I chose. 2 times a -2 is a -4. -4 plus 5 is what? 1? 0 taken back and plugged into 2x plus 5 really gives me a 5. And that table's done. Now let's plot those in the blue and see what at least that much is. Guys, first, -3 down 1. Do it like this. -3 down 1. And looks like I see an equals mark which says I may include that. -2 up 1. Oh, wow, it's up here. -2 up 1. There. 0 up to 5. Let's put 5 right there, guys. And if I go up to 5, right there. Not scale right there. Okay, got this point, this point, this point. Does it look like they should line up? I've got a rough sketch here. Do you think connected they should line up? Now if I connect, here we go. Looks like it's going to look something like this. Not like that. I want that to be more straight. This. And like this. That's supposed to stop there. Should be a piece of a straight line. Now, I notice this side is included. 0 though. Was 0 supposed to be included on my graph itself? So that means this up here, 0, 5 should be open. And then that takes care of the blue. Done. So one side was closed in, the other side's open, and that's my piece of that straight line. Now the second piece, the one in red, it's a gift. It's a gift. You'll say, Professor, can I form a table there? If you do, in the red, all you have is this. When x is 0, y is what? -3. That's all you have to work with in piece number 2. There's no x there to work with. Let's have 1 point. So 0 down 3. Go down here, guys. All these different colors. It's down here. I closed it in. It's done. The one in green, can anyone tell me what shape, piece of, what shape should x squared plus 1 be? A parabola. I see that x squared, so it should be a parabola. Now, how can I get it? Well, we'll plot a few points. And we'll see what happens here. X, Y. We'll start with 0, since I gave 0 to work, for me to work with. But also, I'm allowed to try anything greater than 0 for the x. So we'll try 1. Let's try 2. I'll try 3 there. Take 0 back, put it into my green. 0 squared plus 1 gives me a 1. Put a 1 into the green, gives me a 2. Just plug in numbers. Plug in a 2. 2 squared plus 1 gives me a 5. That should be enough. If not, go back and put more items in the table. Guys, 0, 1. Okay, I've got to find it first. 0, 1, I notice I have no equals mark here, so this should be open. Then I got out 1, up 2. It says right in here somewhere, guys. And out 2, up 5. Or up to here. I have those 3 points. We know the shape should be the shape of a parabola. I would think it's going to look something like this. And see if you guys agree. Is that what the final graph looks like? The 3 pieces. That's true, guys? Does it look something like that? I was right on top of the board, so I hope I didn't make a mistake. Okay. We're going to do more practice with these piecewise functions on Wednesday. Any concerns on this first one? Nah. This, of course, was a giveaway. It's a V-shaped graph, absolute value graph. Now, with all that said, Mr. Park, you've gone through this. Now, if you feel overwhelmed, and I've had classes where I was overwhelmed. I think we've all had things overwhelming before. And I think, oh no, man, this is too much. This professor's crazy. He's expecting me to do all this and turn this in and our test, suppose I mess up on the test and this and that. Things go on. And you get just overwhelmed. We all do. But Mr. Park, when they leave me and they go to the next instructor, Math 7, it may do what?
A benefit.
It may, I hope this course will benefit you, but the coursework, it depends on the professor, the coursework may be more overwhelming. So if you leave me, I may see you later on, you say, oh, Ramsey, I'm in Calc 1 now, Math 7, you are? Why are you crying? Maybe you're out there crying. I said, what's wrong with you? What's wrong with you? Why are you crying? Katie, why are you crying? Oh, Math 7, professor. And Katie gets through Math 7. I see later on, she's in Math 8. She's got one issue. You know, brother, it's crazy. We've all gone through it. You guys have got to do it, and I hope this pre-calc course will get you ready for both Math 7 and Math 8, which I think it will. Don't you think so, Mr. Park? Did it get you ready back in Math 7? Mm-hmm. And Math 8 probably. Okay. Guys, we'll stop here. Here we go. Now, what I would like to do, I want to go downstairs to the math lab. Just one side. This is what's expected of you. These types of problems, just one side, for the quiz on Wednesday. So I will pass these out, and you guys can start working on them. I'm sorry, I love group work myself. I love students in groups, but we can't do it in here. They don't want us to mess the room up. So I'm going to go downstairs, but we'll do the best we can. We'll work on this, Mr. Park. I think